Hi guys! For this video, ang pag-uusapan natin is the second part of our solution dito sa example number 20 na nakikita nyo sa inyong screen. So recap lang tayo nung naganap doon sa part 1 nung solution. So ang nahanap na natin is yung mga moments sa B, C, and D using the three-moment equation, right? So, therefore, dahil doon, ang magiging next part na lang natin is to solve for the vertical reactions of the support and of course the shear and moment diagram of this beam. So, I already sketch the yung paghati-hati ng mga span ng beam natin. So, take note, no, ito yung original na shape. So, 4 meters, 5 meters, 4 meters, 2 meters. So, sa case na ito, dahil this can be solved using statics na lang naman, there is no need naman for us to include the flexural rigidity. Okay? Kaya lang, there is something that I want you to take note. Kung kanina, inignore natin yung 50, di ba? Because 50 acts directly at point B. So ngayon, as you can see, that 50 appears here parang diretso siya sa point B. So while dito sa RC, RC1 and RC2 lang, then RD is RD1 and RD2, simple addition lang naman yan. Dito sa RB, tatlo yung i-consider nyo. Bukod sa magiging reaction dito sa span AB at magiging reaction sa span BC, you need to consider the additional 50 kilonewton reaction na ipoproduce kasi yun na nga, balik tayo dito, this 50 kilonewton will act directly at B. Hindi na niya maapektuhan yung beam, but the vertical reaction of B will be affected by this one. Okay? So, ganun yung mangyayari. Likewise, wag ko na masyadong pahirapan yung sarili ko dito. In span DE, wala naman tong ibang reaction, yung R dito nyo, kundi maging 25. Okay? So, maging 25 kilonewton. And yung MD, alam naman natin na negative 50 yan eh. But for formality, sige lang. Kasi nga, ang goal lang naman natin for this problem is to solve for the reactions. Okay? So, ito na lang. RA, RB1, RB2, RC1, RC2, and RD1. So, let's start in span AB. So, syempre, consider span AB. Here, ang mangyayari, you can use either summation moment or summation forces vertical, no? So, siguro, summation moment at A is equal to 0. So, clockwise moment equals counterclockwise moment. So, for the clockwise moment, yung only clockwise moment is the triangular load, 1/2 ng 15, tapos 4, and 2/3 ng 4 because its centroid is located here, that is 2/3 of 4. Okay? Tapos, there is no other clockwise moment naman. The counterclockwise moment will be MB plus RB1 multiplied by 4 meters. So, here, let me compute ulit, no? Ang gagawin nyo, isa-substitute nyo yung value ng RB which is, sorry no, yung MB which is negative 27.706, di ba? Again, yun yung na-solve natin in the part 1, no? Negative 27.706 plus 4 RB1. I will let you solve this one. You may pause for a while, siguro mga 5 seconds. Ay, sorry, no, i-pause nyo muna. Then, you can use shift solve. Pero, kapag sinolve nyo to, ang mahahanap nyo na RB1 ay equal sa 26.927. Okay? So, kilonewton. For RA, that is easier to do. Summation forces vertical na lang equals 0. So, up equals down tayo, which is RA plus RB1 is equal to the only downward force, 1/2 ng 15 times 4. So, therefore, RA plus 26.927 is equal to 1/2 ng 15 times 4. So the value of RA is equal to 3.073 kilonewton. So may value ka na nilang reaction. So next tayo is i-consider natin yung span BC. So tiyaga-tiyaga lang dito, no? Madali na to kasi statics na lang naman. So consider span BC. So in this case, summation moment at B tayo equals 0. Clockwise moment equals counterclockwise moment. So, ang mangyayari, yung clockwise moment natin, class tatlo, yung MB, yung uniform load, and yung concentrated moment, concentrated force. So, therefore, MB plus 15 times 3, tapos 3 halves, di ba? Ganun yung mangyayari, 15 times 3, times 3 halves, tapos plus 30, then multiplied by 3. And the counterclockwise moments are MC plus RC1 times 5. Diba? Kasi kung titingnan nyo, counterclockwise itong dalawang forces na to or dalawang loads. So when we substitute the moment at B as negative 27.706, wait lang, I need to rewrite this. Negative 27.706 plus 15 times 3, then 3 halves plus 30 times 3 is equal to, yung moment at C is negative 23.679. Then, multiply nyo na lang or plus 5RC1. Again, you may pause this video for 5 or for several time. You can use shape solve. Then, after nun, pag i-ano nyo na, ito na yung equation na isosolve nyo, no? Ang mahahanap nyo dyan na RC1 ay equal sa 30.695 kilonewton. Okay? So, ayan na yung RC1. So, summation, forces vertical tayo, equals 0. So, that is up equals down. So, ang mangyayari, RB2 plus RC1 is equal to, so RB2 plus RC1 is equal to 15 times 3 plus 30. So, 15 times 3 plus 30. So, RB2 plus 30.695 is equal to 15 times 3 plus 30. Kaya yung ating RB2 ay equal sa 44.305 kilonewton. So, ayan. Tapos na tayo sa span BC. So, let's consider span CD na. So, consider span CD. Here, we can do first summation moment at C, di ba? So, summation moment at C. Ang kagandahan dito, let's take advantage of the symmetry of the triangle. Halata naman na the centroid of this is located here. Okay? Ang clockwise moment is yung MC, tapos yung entire triangle, while the counterclockwise moment is yung MD saka RD1. Okay, so isulat natin yan using summation moment at C is equal to 0. Clockwise moment equals counterclockwise moment. So MC plus 1 half ng 20 times 4. Kasi nga 'di ba as I said, 4 meters naman na to and its centroid is kalahati ng 4 meters from point C. Okay? So I hope you understand this. So here magiging 1 half times 4. And that is equal to MD plus RD1 multiplied by 4 meters. We substitute the values of MC and MD. So the value of MC is negative 23.679 is equal to 1 half ng 20. Plus 1 half ng 20 tapos ng 4, then 1 half ng 4. Yung MD naman natin is negative 50 yan, di ba? Plus 4RD1. So, the value of RD1, again, pag sinolve nyo siya, that is 26.580 kilonewton. Meanwhile, summation forces, vertical tayo equals 0. So, up equals down. Wala naman tayong choice. Ang up kundi RC2 plus RD1. And yung downward is simply itong triangle, di ba? Yan lang naman yung downward dyan, yung triangle. That is 1 half ng 20 times 4. So, RC2 plus 26.580 is equal to 1 half ng 20 times 4. Kaya, ang RC2 natin ay equal sa 13.420 kilonewtons. Okay? So, ayun. Tapos na tayo sa analysis kasi yung RD2 naman is 25. So, kapag nahanap nyo na yung mga values nitong mga vertical forces, the next step na lang is to merge again the given beam. Okay? So, by merging them, so halimbawa, ito na yung beam natin eh. Then, let's sketch or let's draw the given beam, no? So, dito, since this is statics na nga lang, wala na dito nga masyadong involvement yung ating mga EI, okay? So, this is 15 kilonewton per meter and diretso nga siya. Ayusin ko nga yung sulat ko, napapangitan ako sa sarili kong sulat, no? So, 15 kilonewton per meter and ito yung 30 kilonewton. Then, syempre, we have this triangle na 20 kilonewton per meter. And lastly, yung overhang na 25 kilonewton, part pa rin naman siya ng beam natin. So, this is point A, B, C, D, and E. Let's place the distance 4 meter, 3 meters, 2 meters, 2 meters, 2 meters, and 2 meters. So, ngayon, ang gagawin natin, hanapin na natin yung reactions. So, halimbawa, for A natin, ang RA dito, well, of course, wala naman ibang RA. Nasa span 1 siya, and that is 3.073 kilonewton. Okay? So, 3.073. Nakalimutan ko pala yung 50 dito, no? Meron pa tayo ditong 50 kilonewton. Of course, for the value of RB, proceed tayo dito. Yung magiging value ng RB class, ang gagawin lang natin dito is simply to add the values of RB1 and RB2 tapos yung RB3. So therefore, 26.927 plus 44.305 and syempre plus 50. So that is equal to 121.232. Okay? So I have my own ano na kasi nito copy. So this is 121.232. So sa case naman ng RC, well, ang gagawin nyo lang naman, just add RC1 and RC2. Kasi nga, di ba, ito lang naman yan, RC1 and RC2, 30.695, then 13.420. So, that is 44.115, no? 44.115 kilonewton. And lastly, for the case of our RD, dalawa yung RD natin, no? RD1, which is, nasa na yung RD1? Ito, 26.580. But, take note, meron pa tayong RD2, which is simply 25 kasi babalansehin mo lang naman yung forces dito, 25 siya. So, pag pinag-add mo yung 26.580 saka yung 25, the answer is 51.580. So, kung babalik tayo doon sa tanong, again, kasi yung unang nahanap natin is the or are the moments, no? So for the next questions, the reaction at A is equal to 3.073 kilonewton. Yung reaction ng B ay equal sa 121.232 kilonewton. Yung reaction ng C is equal to 44.115 kilonewton. And lastly, yung reaction at D is equal to 51.580 kilonewton. So, ayan na. Na-solve na natin yung mga reaction. So, proceed tayo sa last item, which is of course sketching the shear and moment diagram. Dito na yung pagkakataon yung magdasal na sana mabalanse yung diagram natin. Okay? Let me draw the guidelines na kekailanganin natin in our analysis, of course. So, wait lang. Siyempre, pa-dash-dash pa yan, no? Oh, okay. So, let's start drawing the shear diagram. Ito yung hindi kailangan ng masyadong milagro, no? Kasi madali siyang mabalanse. Sana lang, no? So, for the shear diagram, let's start sketching that one. So, sige. Oops. So, ngayon, syempre, yung shear diagram magsisimula sa pagtaas ng 3.073. Okay, so this is 3.073. Well, of course, ang next step dahil triangular siya, siguro ilagay ko nga din tong calculator ko, no? So, 3.073. Then, minus 1/2 ng 4. Tapos, 15. So, ang sagot natin is negative 26.927. Yung magiging kurbada niya, pa ganyan. Okay? So, let me arrange lang, no, the diagram. Negative 26.927. Or 26.927 na lang. And of course, alam naman natin na this is a second degree curve and yung point of intersection na yan, that is the location of the maximum positive moment for AB. Kaya lang, syempre mahirap yan gawin na i-square property, no? But wag kang mag-alala, may technique ako dyan na gagawin mamaya. But for the meantime, let's focus for the shear diagram muna. Okay? So, for the case of shear diagram, after nyan, ang gagawin natin is, i-consider na natin yung pataas na 121.232 kasi yun yung reaction eh. But, do not forget na may direktang pababa na 50 dyan. So, may minus 50 pa dyan. So, our answer is 44.305. So, this will be 44.305. Then next tayo, minus 15 times 3. 'di ba? Because of this, minus 15 times 3. So, ang sagot is negative 0.695. Sobrang liit niya. But still, dahil negative siya, ibig sabihin nag-intersect siya dito. Negative 0.695. Okay? Then, of course, you need to consider itong 30. So, minus 30 din. Negative 30.695. So, negative 30.695. And wala ditong load, so ibig sabihin, distributed lang siya. Then plus 44.115. So ang sagot natin ay 13.42. So 13.42. Then next tayo, i-consider natin itong triangle na to. Minus 1 half ng 2 times 20. So, ang sagot natin dito ay, sorry. 13.42 minus 1 half ng 2 tapos 20. Ang sagot ay negative 6.58. So, here, negative 6.58. Then, syempre, another triangular load na negative ulit. Minus 1 half ng 2 tapos 20. So, negative 26.58. So, negative 26.58. So, syempre, itong mga intersections na to, napaka-importante niyan because that is the location of the maximum moment. Then, syempre, plus 51.580 pa. 51.580. So, that is positive 25 na. Then, pababa, and syempre, may pababang 25. Ayun, nag-close yung ating shear diagram, which is it should be, no? Kapag hindi yan nag-close, delikado ka. Sa moment diagram, mahirap na to class computein manually simply because our figures are somewhat complicated. Halimbawa, paano nyo hahanapin yung area dito, at the same time yung area nito. Ito okay lang, triangle. Wala siyang problema. But going back here, how can you solve for the areas, no? So ako, ang gagawin ko na lang, when sketching moment diagram, minsan nagte-technique na lang ako, no? Para lang ma-obtain ko yung mga values nila. So, hindi naman siya talaga pandaraya. Pero, ayun na nga, may tiwala naman ako dito sa dati kong solution. So, ibig sabihin, dahil nabalanse ko yung shear diagram, so feeling ko, mababalanse ko rin naman yung moment diagram. Okay? So, halimbawa, kasi yung mahirap dito is yung paghahanap ng mga positive moment, no? So, let me draw. So, halimbawa, dito sa part na ito, for the first beam, alam ko na ito yung point of maximum moment. Ang problema ko na lang is yung value niya. So, therefore, I will sketch a moment diagram na pag ganito siya. 'Di ba? Because here, alam ko sa point B, yung na-compute kong moment ng B is 27, no? 27.706. Sir, saan to galing? 'Di ba yung na-compute natin na moment ng B is negative 27.706? So, kumbaga, alam ko na magiging ganyan yung itsura. So, even though hindi ko alam kung ilan yung mga numerical values nila, pero based sa behavior ng figure, magiging ganito agad-agad yung kurbada ng moment diagram ko. And yung concern nga natin, ito, paano natin mahahanap yung maximum moment. So take note, magilalagay ako dito ng bagong scratch for span AB. Alam natin na 4 meters yan, no? So this is span AB. At the same time, yung reaction sa A ay 3.073 kilonewton. At the same time, this is 15 kilonewton. So, if I let this as x, kasi ganun yung technique ko dito eh. If I let this as x, this will be 15 over 4x. Okay? So, I want to cut that. I want to cut that part. Tapos, I want to solve for the value of x. Okay? So, ang gagawin natin, kasi one of the problems here is the value of x eh. So, 3.073. So, of course, this is the maximum moment. And take note, sa point of maximum moment, babalik ka doon sa behavior natin na ang shear ay 0. At the point of maximum moment, the shear is 0. So, this is x. And syempre, 15 over 4x. So, ganito yung ginagawa ko kapag hindi ko na alam kung ilan yung value dito. I just cut this and summation forces vertical equals 0, up equals down. So, 3.073 hindi na kasya. Maybe I will use na lang the space downward, no? So, here, ang gagawin natin, summation forces vertical equals 0. So, up equals down. So, therefore, ang gagawin ko, 3.073. Ang up is equal to 1 half ng x. Tapos, 15 over 4 ng x. So, ang sagot natin dito for the value of x is 1.2802 meter. 1.2802 meter. So, ibig sabihin, I have the value na 1.2802 ito. So, I don't need the squared property, so on so forth. Ang kailangan ko lang is knowledge of the statics kasi diba, tingnan nyo, yung shear dyan, 0. I just place na yung shear ay 0. And of course, by using summation moment is equal to 0, ang mangyayari dito, class, when obtaining the moment, actually, na-lesson ko na to yata doon sa part 4 ng sa pag-drawing ng shear and moment diagram. If the shear and moment diagram is somewhat complicated like this, the best way is to cut. Then the point of maximum moment is simply the point of zero shear. So patuloy ko lang to, but I will not do that here, no? Dito sa remaining points, I will let you do that by your own na lang, no? Okay? So for summation, moment equals 0. Ang mangyayari, 3.073x is equal to 1 half ng x, tapos 15 over 4 ng x, then 1/3 ng x, plus m max, no? I will let you substitute the value of x na equal sa 1.2802, kaya ang maximum moment dito is 2.623 kilo Newton meter. Okay? So, this is 2.623. So, ganun yung technique ko dito. Next tayo, for the next one, ang mangyayari, based dito, this will form a parabola pa. So, therefore, kurbada pa. Pero pagdating dito sa may pababa, that will form a straight line na lang. Yung moment ng C natin is equal to, take note, no? Yung moment ng C ay equal sa negative 23.679. So, dito, ang gagawin ko, I already solved this manually kasi before providing you a record. So, tataas yan, papunta dito. Pero dito, kaya mong mahanap yung area eh. Kaya mo siyang mahanap. But I will let you do that na lang. So, this will be negative o positive 37.725. 37.725. Then, pabagsak siya dito. Then, after nun, dire-diretso lang yan. Tapos, straight line yan hanggang sa ma-reach niya nga yung moment sa C na negative 23.679. Okay? So, ito na siya. Straight line. Okay? So, negative 23.679. Lastly, dito sa panghuli class, unfortunately, yung span CD, wala itong positive moment. If you are going to cut here, siguro, yung span BC, I will let you do na lang the area. So, negative 27.706 tapos dito, or you can simply cut. But for span CD, I can prove you na wala siyang positive moment. So therefore, although ang magiging sketch niya, kasi the moment at C is negative 25, right? Or yung moment at D, that is negative 25. So that might look like this. Negative yun eh. So pag in-expand natin siya, ang mangyayari doon sa diagram niya, pag ganito. Tapos ito negative 25 kasi nga 'di ba, the moment at D is negative 25. Then yun na nga ang kagandahan dito, negative 50 sorry. Hindi siya negative 25, negative 50. So ito siya, negative 50. Then i-straight nyo na siya kasi 'di ba, negative 50 plus 25 times 2 is 0. So this is the look of the moment diagram. Kaya lang, as I said, I will prove to you na yung span CD is walang positive moment kasi yun na nga, although aangat siya, hindi siya ine-expect na yung pag-angat is mapupunta dito. So, how can I do that? So, balik tayo dito sa original na beam natin. Ayan siya. I will simply paste that. And of course, may mga values naman na tayo ng MC. But as you can see, the point intersects dito sa unang half ng ating triangle. Okay? So since it intersects in the first half, so I will simply consider this portion lang of our analysis. Take note na may value pa tayo ng C na i-consider for the moment ng C. And I will write the given, yung RC2, na-compute na natin siya kanina as 13.420. Tapos, yung MC is equal to, ilan siya? Yung MC natin is equal to negative 23.679. And syempre, pag nag-ratio and proportion tayo dito, this is 10x and this is x. So again, this is the maximum moment. And sa case natin, syempre, the shear is equal to 0. So summation forces vertical is equal to 0, up equals down. So that is 13.420 is equal to 1 half ng x tapos ng 10x, then plus 0 kasi wala naman ng ibang downward. So, yung value ng x dito ay equal sa 1.6383. So, ibig sabihin, even though nga hindi ko siya kayang ma-squared property, so this one is 1.6383. So, di ba no? Yun yung magic. And syempre, para mahanap nyo yung moment, so summation moment na lang at x is equal to 0. Clockwise moment equals counterclockwise. So, yung clockwise moment natin is RC2 multiplied by x plus MC. Then, ano pa? Nope. Clockwise. Yes, clockwise. And yung counterclockwise is 1 half ng x, then 10x, tapos 1/3 x. Then, syempre, yung M max. I just want you may pause this for a while. I want you to substitute negative 23.679, tapos yung R as 13.420, and yung X as 1.6383. So, kapag sinubstitute nyo yan, ang mahahanap nyo ay, I will not do that here, no? Ang mahahanap nyo na lang dito na M max is negative 9.022 kilonewton meter. So, yun na nga, dahil negative, ibig sabihin, umaangat nga siya. Okay? Umangat siya. Pero, hindi sapat yung pag-angat. Kaya ang nangyari, that is still part of the negative moment. And that is common pa rin in the beam. Okay lang yun. Normal yun, class, sa ating mga beam. So therefore, it may sound ridiculous itong, or it might look ridiculous itong moment diagram natin. But ito yung itsura niya. So wala naman tayong choice kundi kailangan natin adapt. I hope no alam kong medyo confusing itong technique na to. I'm aware of that. Maybe you are watching right now. Maybe nagjo-jaw drop kayo. Hala, paano to? So if you want to master this technique, yung pagkakat na lang na instead of mag-squared property whatsoever, I suggest you to rewatch yung aking lecture videos for chapter 4 sa structural theory. Yun yung pag sketch ng shear and moment sa mga statically determinate beams. Nevertheless, we can now conclude dito kasi natapos na natin itong napakahabang problem na ito. So, yung tanong for letter H, what is the maximum positive moment at AB? So, ang sagot natin ay 2.623 kilonewton meter. For BC, yung ating maximum positive moment naman ay equal sa 37.725 kilonewton meter. And of course, for CD, we already knew na yung maximum positive moment is not existing. So, no positive moment. Kasi nga, umaangat naman siya, pero hindi nga sapat. So, ayan. Suma total, lampas isang oras yung pag-solve ng ganitong problem. Well, expect na ganyan talaga sa structural theory. Pero I still hope na this gives clarity sa pag-aaral nyo regarding the three-moment equation. So, thank you so much for listening and watching. And I hope nga na okay kayo dito. So, ingat kayong lahat.